this week's edition of the Pete Mezzetti Show. My guest this evening is student meteorologist Eric Weglarz. Eric, welcome.
Thanks for having me, Pete.
How are you, buddy?
Good. How about yourself?
I'm good, thanks. I'm good. So for our viewers and our listeners that don't know who you are, I guess who is Eric Weglarz and how did he get interested in meteorology?
Great question. A lot of people ask me this, to which I kind of scratch my head and go all the way back. So my name's Eric Weglarz. I am a junior at Linden State College studying atmospheric science. That's a fancy term for meteorology.
All right.
Being a weatherman on TV is one of our tracks that we have up at school. I attended Haddon Killingworth High School, oh God, all the way back, way long ago, starting 2008. Wow,
Okay.
It's been a while.
All right.
So I started then, and I joined the TV program in 2010.
Right.
And I became a weatherman in part then. Mr. Lewis kind of nudged me in that direction, started from there. I liked weather way before that, but that was kind of the stepping stone, I guess you could say, to where I am now.
There you go.
So from there, I graduated. Mr. Lewis recommended me to go to Linden.
Yeah.
I was recruited by some admission staff up there. I came to Linden, and here I am.
There you go. You like it?
I do. It's cold. It's very cold. Northern Vermont is not a place that you want to be in the middle of January with, a light jacket on. You'll get frostbite. It's very cold.
I was going to say, has it snowed up there yet?
It has. We've had some snow, snow showers here and there the last couple of weeks. Nothing's really hung around all that much. We've had a couple inches here and there, but nothing substantial.
I was going to say, nothing's on the ground. It probably just hits the ground and melts.
It was a couple inches. I mean, it's very cold there now as opposed to what it was, say, 3 weeks ago during Christmas.
Right, exactly.
When it was 60 degrees. That's
right.
not the case anymore. So.
No, exactly. So I guess we're going to start tonight's discussion talking about El Nino.
El Nino.
Let's talk about El Nino.
So El Nino has been huge in the news, as I'm sure many of you have heard, and you've heard especially too, and how it's driving the weather. We talked about El Nino and the predecessor to that, La Nina. And it's two different spectrums that we have in the weather. So first off, El Nino, we have a graphic of this we'll show, is
I believe we do.
It's warming in the ocean. So it's an abnormal amount of warming that occurs. And as a result, you get this warming of a shift in cold patterns downstream and the jet streams as well. So during an El Nino, you have we can think of jet streams as there's not just one jet stream that goes across the earth and dictates everything that happens. There's a couple different ones that we like to look at. So we have a polar jet, we have a subtropical jet. Now during El Nino, the subtropical jet stays to the south.
Okay.
So it remains detached and far away from the polar jet that we see to the north. Now during the winter, it gets pretty cold, as you know.
Yeah.
The polar jet sinks to the south across the United States. Cold air follows right behind it. And we get that cold air that builds in, and usually we'll have the subtropical jet meet up with a polar jet and you get these winter storms, these nor'easters.
Right.
That's not the case in El Nino. The subtropical jet stays to the south, so it stays across portions of Arizona, California. California has had a massive amount of rain and a massive amount of snow. And into the southern states and the southern plains across portions of the southeastern United States, they have a tremendous amount of flooding. Subtropical jet's very moist and in turn brings all this moisture here. But how it affects New England per se is the fact that it's very dry and very warm, above average temperatures, as I'm sure many of you have been feeling so far. Lack of snow is definitely one of those things. Winter is dictated more by El Nino as opposed to the summertime.
Right, exactly. Now, what else can you tell us about El Nino that our viewers and listeners might find interesting? So
again, we talked about the difference. So if we go to La Nina, we have another graphic as well here.
Sure.
With La Nina, what will happen is, when we have a strong La Nina, you'll have a huge high-pressure system off in portions of the eastern Pacific.
Yep.
Sometimes we'll skirt over to portions of western California. And what happens is the polar jet, which typically will go zonal, so west to east, or it'll be a little bit wavy, suddenly shoots up across portions of Alaska. And as this happens, what happens on one end, so if it shoots up, it has to come down somewhere. So it comes down into portions of the central United States, and as a result, that cold air comes in, and we see this cold blast behind it. Now, the subtropical jet that I also mentioned earlier infuses itself very close to or within the polar jet, giving it the moisture you need. And when these jets combine, you get some crazy storms, get some nice nor'easters along the East Coast, giving us that snowy winter. Not this winter, but last winter we saw a ton of snow.
Oh, yeah.
It was a weak to moderate La Nina that gave us.
I was going to say lots of snow.
Yeah, a tremendous amount of snow indeed.
Exactly. I'm sure it snowed up in Vermont as well.
It did. We had a lot of snow, but the main story I think last year was more Boston. Boston saw snowstorm after snowstorm after snowstorm to the point where they're melting it. I've never seen that before.
Some more's coming.
Yeah.
Exactly.
Indeed.
Exactly. Now, as far as I guess it's been shaping up this winter with the weather, and do you think it's ever going to snow?
Yes. And as we talk about this, we're watching storms farther down the road.
Right.
In this pattern, and with an El Nino so strong as it's been, it hasn't been the strongest El Nino that the Climate Prediction Center has records of. It's been very strong, very close to that, but not the strongest.
Right.
It's very hard to get a grasp of the climate downstream, or how the pattern changes downstream.
Right.
So as a result, you want to forecast these snow shots out. Say weather models now can go 7, 10, 15 days out. So say I have a model and there's a storm, 7 days out.
Right.
Snowstorm, 7 days out. Awesome, yeah. That's going to change, between that 7-day period as we get closer.
Right.
So I could tell you for certain that when we tape the show, that Friday and Saturday we're going to have a snowstorm.
Right.
That's going to probably change between now and we talk about it. So it's harder.
All right.
Harder to discuss.
We're not going to talk about it.
I can give you a little hint so far. El Nino hasn't really backed down in the regions that mostly affect us. Now, there are other pieces to that teleconnections puzzle as far as how we dictate our winter. But as of right now, it's going to be harder to get snow, at least down in southern New England as of right now. Places up to the north, they've gotten it. So portions of northern Massachusetts, northern New Hampshire, Vermont, they've seen some snow.
Wow.
It hasn't been that, that crippling 32 inches of snow we get in a single storm.
It hasn't been crazy
it's
snow.
been much less, much drier.
Now, figure this out. As far as when you obviously, if you're inland and you're on the shoreline, or you're up the 95 corridor, or if you're up the Route 9 corridor, let's say it's snowing down on the shoreline and it's raining up north. Why does it do that? I guess what's the effect of?
If it's raining inland and snowing at the shore, there's a serious weather problem that I'm not familiar with as far as Connecticut weather is concerned.
Right.
Usually that happens in flips. So you'll have it's raining at the coast and you'll have snow inland.
Yeah.
So what happens, especially when we get into the very start of winter? So we're talking about December, November, December.
Right.
Water has a higher heat capacity, so it likes to hold on to heat longer as opposed to other objects.
Okay.
So what will happen is, along the immediate shoreline, you'll have much warmer waters in Long Island Sound and off into the Atlantic. So when a storm develops and moves inland, you might be warm enough at the water where you're going to stay on to rain for the majority of the storm because it's warmer directly right off the water.
Right.
So say you're in Westbrook, for example, and you go out and the water's right here, you're going to more likely keep on to that rain. Now, if you go inland, things have had a chance to cool, so the land doesn't hold on to heat as well as water does.
Yeah.
So you'll see snow in the land as opposed to closer to the shoreline first. Now, as we go on throughout the winter, so as we go more towards January and February, and the water has had a chance to cool off, that's when things switch around. So you see the rain-snow lines we talk about, you'll see many times talk about in weather. So you start with the rain-snow line, maybe towards Chester and Haddam, for example, in Middlesex County.
Sure.
And it'll kind of battle it out there. You'll start to see that line, climatologically speaking, as you go on through winter, it'll start to come down a little bit closer to the shoreline as the waters get cooler, and you have less of an effect off the ocean. Now, another instance we might have this rain-snow line is with the warm front.
Right.
So if a warm front that comes up, so say we have a nor'easter. You have a warm front that develops out in the right quadrant, as we say, of the storm. As the storm moves up, your warm front moves up, initially you'll have snow. So cold air will kind of hang in tough, and you'll have snow to start. But as the warm front advances, you'll switch from snow to rain, starting at the shoreline first, and then as you work your way inland, as the cold air gets eroded away. So you start at the shoreline, they'll hit snow, they'll mix the sleet, freezing rain, and rain. And as you move farther inland, that transition happens, and that's why you get that rain-snow line.
Exactly. Now, as far as one thing we didn't talk about, which I would sort of like to talk about right now, with you being a student meteorologist, how intense is it as far as like studies go? And
very intense. So people sometimes don't realize that student meteorologists, at least many programs have this, you have to know a good deal of calculus.
Right.
The atmosphere is governed by a lot of math, as far as we understand it. So dynamics is very heavily calculus-based. So you have to take Calculus 3. In my case, some schools require differential equations, which is like calculus on steroids. And essentially, you learn about the atmosphere. I could start throwing out equations right now, but I don't think we want to talk about equations.
No, we're not talking about
But you will have these equations that are governed largely by calculus. You have to understand it. You have to know how to integrate it and derive it and all those things, and be able to, again, understand the atmosphere through calculus. Weather models are largely driven by differential equations that allow you to understand how the atmosphere models through time whether it's growth of a raindrop, et cetera, to how your winds move through time, how temperatures in fact through time,
Right.
through a given location.
Exactly. Now, as far as what else do you want to tell our viewers and our listeners about the wonderful world of weather?
Oh God, there's so much of it. In my spare time, I like to storm chase. So I will go to select locations in New England and storm chase. I don't recommend that you do this at home. This is not something that you should just go out, say one day, I'm going to go storm chase. It's a terrible idea here. And for many reasons, one of which is we're surrounded by trees.
Yeah.
And we have hills, but we have a lot of trees. So, if you're chasing down Route 9, you can't see a storm coming.
No.
So, in a way, this is more so for experience. I'm a Skywarn spotter, so I have the ability to go out and report for the Weather Service. And when I see, say for example, a tornado comes through and moves through portions of Middlesex County, I'll be able to report that in and track it as long as I'm not getting in the way of it and risking my life. I've storm chased in Massachusetts. We hit a couple of cells, not last year, but the year prior.
Okay.
That were tornado warned. They died out as they came closer to the maritime influence in eastern portions of Massachusetts. It was fun. We saw some damage, which isn't what you want to see ever, but we got to see how a storm really develops, blossoms, and then unfortunately dies out.
Right.
And we got to see mainly destructive winds across the towns that we were in. But it was a good learning experience. It really paved the way for my severe weather interests that I've developed all through high school and middle school when I was a younger kid.
I was gonna say, what are some? Do you have another favorite season besides to go like storm chasing?
Oh boy. I mean, like season or more so place, I guess.
Place. All right, we'll take place.
I've tried in Vermont unsuccessfully.
Oh no.
If you think chasing in Connecticut and Massachusetts is bad, Vermont's just terrible. The Green Mountains, when we look at thunderstorms, they can thrive on mountains.
Yep.
But what happens in Vermont and where I'm at school, I'm on the eastern side of the Green Mountain Range.
All right.
So storms will generally move from west to east or southwest to northeast, or even northwest to southeast, and that general motion across Vermont. So I'll sit on the other side of the Green Mountains, wait for the storms that are doing so great as they come across the mountains, and then they come across the mountains and the mountains kill it.
Ah.
So I will go out, I chase, I see something on radar, and it's really not as decent as advertised. And that's just a fact of life. We have had, I left for college, I think it was my sophomore year, and we had a tornado warning a week after I left for college, about a mile from the college.
Oh no.
And they ended up just taking off parts of somebody's roof on their barn. And so you'll get these weak spin-ups and thunderstorms in Vermont, but they're not as significant as they are down here.
Would you mind sticking around for another segment?
Awesome.
We'll be right back.
Jimmy can't sing and Tommy can't dance, so we're gonna put some ants in their pants. Aww, they walk like a monkey, hop like a bunny. Isn't that funny? Ants in their pants, they got ants in their pants. They've got ants in their pants, they got ants in their pants. Ants in their pants, they've got ants in their pants. They got ants in their pants. They've got ants in their pants.
One more time.
Jimmy can't sing and Tommy can't dance, so we're gonna put some ants in their pants. Aww.
Kids will spend 22 minutes watching us, the super duper party troopers, sing about ants in their pants.
Isn't that funny? Ants in their pants, they got ants in their pants. They've got ants in their pants, they got...
Brushing for 2 minutes now can save your child from severe tooth pain later. 2 minutes, twice a day. They have the time.
And welcome back to this week's edition of the Pete Mezzetti Show. I'm your host, sitting here with student meteorologist Eric Weglarz. Eric, welcome back.
Thank you.
Thank you. So I was wondering, we can talk maybe a little bit about some of the weather patterns and how they dictate?
We can. So I mean, one of the biggest things I think we have here in the winter that we're always so in tune with is snowstorms. We want to have we want to have a day off from school.
Right.
So one of the most hard-hitting snowstorms we call nor'easter, or it's a massive low-pressure system, and we've had a few that even I can recall, even back at my high school years, that have literally just crippled the state in the course of one storm. So I guess we'll discuss a nor'easter. What exactly makes it so special? Sure. Where does it form? Where does it start?
Yeah.
So you'll have low-pressure systems. We talk about how a normal jet stream looks like in the winter, in a way, how you'll have storms that develop and they'll move along and move towards the northeast. So usually they start out in places like the Carolinas. So you have low pressure that develops off of these coastal locations.
Okay.
And as they move forward, they develop energy. So usually, sometimes you'll have a low pressure system that's off in portions of the Great Lakes that moves into Ontario, or even a little bit farther south than that. And that storm transitions its energy to the coastal storm. It's a transition of energy. We call it a Miller B type storm. So as it transitions its energy, it explodes.
Right.
Now, the great thing about nor'easters is that they tend to explode given the exact track right next to us.
Right.
So we get this huge swath of precipitation. We get a coastal front that'll develop snow along eastern portions of Massachusetts and in New Hampshire, and suddenly they get 3 feet of snow.
Right.
So we have all this precipitation that just amplifies, all of this energy amplifies and just blows up right over us. So when we talk about snowstorms, we look for the 4070 benchmark. It is longitude, latitude.
Okay.
It's almost a bullseye. So if a storm is on that benchmark, you're going to have a major nor'easter depending on, again, how strong the storm is, how much energy there is, what the precipitation looks like. All of these factors help us dictate, again, this is going to be a big snowstorm. Now, as snowstorms stray farther inside that benchmark, closer towards Cape Cod and southern New England, well, that's more rain for us. We talked about how the warm front moves in and overruns that colder air at the surface. As the storm moves closer in towards places like Cape Cod, eastern Connecticut, Long Island, and Rhode Island, as the storm moves like that, you start to get more of that warm air overrunning. It works great for places like Vermont. Those are Vermont's super intensive snowstorms. They get 20 inches plus of snow. Vermont likes those snowstorms. They don't like the nor'easters that we're typically we're accustomed to.
Right.
They want those storms that move farther in, closer towards places like Cape Cod, that get more precipitation up their way, as opposed to what we tend to hog down here.
Exactly. And as far as let's talk hurricanes.
Oh boy, that's one thing that people hear hurricane here like, oh, hurricane, yeah. Florida, yeah, Texas. Hurricanes have done quite a number up here. Connecticut, we've been lucky. I think that's one thing people, if I say that to you, might be like, well, what are you talking about? We're not lucky. We've had Irene and Sandy.
Right.
If you look at Irene was a tropical storm, first of all.
Correct.
Sandy is an extratropical cyclone. Now, that's a little bit confusing for some. I can kind of help.
Go ahead.
Help, give a little bit more definition to that. We'll start with Irene first here. Sure. Irene was a tropical storm. And when we look at a hurricane, think of a hurricane, you're going to look at the eye and you're going to draw a cross in the dead center of the eye. Okay. Now, when you look at that cross, I'm going to do this with my hands here. And this portion of the cross is where the strongest energy of a hurricane tends to be as far as winds are concerned. Okay. So that we call the northeast quadrant. It's one of the most damaging parts of the storm. Now, we got hit with the northeast quadrant during Irene. That's why we saw all of the power outages that Connecticut had. Right. Remember that CLMP had a difficult time trying, it caught everybody by surprise. Nobody knew that a storm could do that. Exactly. It's been a long time. We had Hurricane Bob in '99. Yeah. That was the last time we've seen a hurricane make landfall anywhere close to here and do a significant amount of damage. So that's what happened with Irene. With Sandy, what happens when we have an extratropical transition is you have a hurricane, it's a nice warm core, it's very bunched up. When it comes to extratropical, it tends to expand. Right. So Sandy was a big hurricane at the time. So as it moves up, it's chugging right along, and then it transitions to extratropical, gets scooped up by a trough that's coming across. Right. As it gets scooped up, we use the term retrograded for Sandy, which is very unique about the storm, is it moved left, and moved left directly into portions of New Jersey. Okay. So as it was making this transition, it was becoming huge. We're still in that northeastern quadrant part of the storm. Okay. As it's expanding, the wind fields expand with it as well. So we get hit with a second wallop of storm surge and massive amounts of winds across portions of southern New England. But we look at the storm surge we saw in Connecticut, so places like East Haven that got hit pretty good. They haven't really seen a direct landfalling hurricane like we saw in 1938 when we had the Long Island Express tear through portions of like New London, Groton, wiped out the railroad, wiped out everything. That is what we have to be careful of. People haven't seen this in a lifetime. So when we talk with, as meteorologists, we say, when we talk about a weather event, how do we relate it to the public? We say, name that storm off. They'll remember that one. Right. We don't have a hurricane fresh in everybody's minds that they can go back and say, I remember that. I know exactly how that happened. I need to move. I need to protect myself. So when the next hurricane comes, I think it's going to be a little bit difficult for emergency managers, for people who are, in trying to get everybody situated, get everybody away from the coast, get everybody to protect themselves. How do you relay that message? I think that's the hardest part for meteorologists too, is to say, this storm is exactly like, say, the hurricane of 1938. Right. Well, not many people are alive for that. Many people were just born and that sort of thing. So that's what my biggest struggle as a meteorologist is to relate this to the public, to make sure that they understand more so what this system truly can do as far as power, as far as winds, rain, storm surge, all of those factors.
Now let's talk about temperature in two different locations.
Indeed. So we can start at the coast. So we talked earlier about how the water has a higher heat capacity. So we'll start off in the spring.
Okay.
So in the spring, normally the water's going to be cool. It hasn't really had a good time to heat up yet. So the land in this case is going to heat up faster in inland sections as opposed to the coastal locations. The coastal locations will remain cooler than the inland locations. So we'll compare, say, Clinton to Middletown.
Okay. Sure.
Middletown is going to heat up much quicker, and it's going to hold on to heat a little bit, and then it's going to cool down as the night goes on. Now, with places like Clinton, they're going to be by the water. It's kind of cool. They won't really warm up as much. So you have a land breeze that develops. So you have a breeze that blows, and this you see this very commonly in portions of Massachusetts. We have a breeze that develops inland and moves towards the water, and that's because that it is so cold at the water, so warm inland. You have this air mass that sweeps from warm to cold. You have this breeze that develops. Now this flips in the summertime when the land starts to cool down, but the waters are still warm. You have a sea breeze that develops, which will inherently keep locations warmer along the immediate coast as opposed to places farther inland. Now, you don't really see this in Connecticut all that much. You'll get these sea breezes during the summer, and towards the wintertime, you'll see them moving on Doppler radar. You'll see these sea breezes develop. Right. But for the most part, these are very, very typical in portions of Massachusetts, where that gradient is much, much more noticeable, and therefore these breezes do develop.
Now I was going to say, let's talk a little bit about the land versus sea breezes.
So yeah, we just discussed how that plays a part. We can go into a little bit about how that dictates severe weather. So when you have a sea breeze, and this sea breeze develops, you can actually cut off severe weather. So a sea breeze is maritime air. It's much cooler as opposed to a thunderstorm that really likes really warm, moist air mass. So say we have a thunderstorm that develops along portions of northern New Haven County in Connecticut. You have a thunderstorm that moves from Fairfield County, moves into New Haven County. Now the sea breeze develops off of the sound and then moves its way inland. So you have this cooler sea breeze that's going to essentially come up to this thunderstorm. The thunderstorm wants that really, very warm and moist environment. Right. The sea breeze is very cold and very, very stable. It's going to cut off the severe weather. So we've noticed that during the summertime, immediate coastal locations usually tend to stay very, very storm-free, at least to start off the severe weather season. That's because the sea breezes that you get basically just cut off the thunderstorms that you'll have. Now, what we've noticed too is that the Connecticut River also tends to kind of inhibit things. So as you have storms that develop across western Connecticut and move eastward, down here we've noticed this a little bit too, is that you will have these storms that come up and then they die because the river is much cooler. Now, as it warms up during the summer, that tends to die off more. So you'll see storms that tend to last longer, come over the river, even blossom up a little bit as they move towards a place like East Haddam, Haddam Neck, East Hampton. Places east of the Connecticut River, they'll tend to blossom up again, and suddenly you have more storms that develop east of the river.
I was going to say, we've got a few more minutes left. Let's talk about Hurricane Sandy and the way that it affected the state.
Absolutely. So Hurricane Sandy, again, I talked about how it's very unique for a couple reasons. We don't have a cyclone that becomes that massive and does so much damage. And the NHC at the time was having a little bit of trouble conveying this because it's not a hurricane. You can't call it a hurricane. It doesn't have the characteristics, but it's still doing the damage of a hurricane, still producing 70, 80-mile-an-hour winds and a storm surge of 12 to 15 feet. It's a massive storm. So Connecticut, it's seen Irene. It's definitely been able to see Irene and see what's happened during Irene. So we kind of had an idea. Okay, we know there's a system coming. It's not necessarily a hurricane like we hear hurricane. Okay, serious. Yeah. Extratropical cyclone. What's that? So what happened was, same principles as Hurricane Irene. We had a ton of wind that came across portions of eastern Long Island, and you had water that piled up Long Island Sound and then moved northward. So it impacted portions of East Haven, all the way down to portions of Rhode Island. I visited Misquamicut after Sandy had come through. Now remember, Sandy hit New Jersey. We're talking about Rhode Island here, which is a considerable distance away. Yeah. There was so much sand that had gotten blown off of the beach into portions of the roads. They had to take payloaders and move all the sand off. They had 200-foot piles of sand in the parking lots because there was so much sand. So the biggest thing from a storm like Sandy is when it retrogrades or it moves west, and you're on that northeastern part of that storm, the biggest thing that Connecticut should be prepared for, especially coastline communities such as where we're in, so Clinton, Westbrook, Saybrook, Essex, is that storm surge. Where do those winds really play a factor, and how much water do you have piling up? Now these storms, as they get stronger, as we see a hurricane get very closer, much closer than what we've seen, that's the main issue. Is something like Sandy has happened, but wait till you see something that's actually a hurricane with stronger winds and more intense of a storm surge, what that's going to do to coastal communities. That's going to do even more damage than what we've seen. That's going to be a wake-up call for some people that have their homes in the water that aren't really used to that.
I was going to say, what do you think that they could come from that?
If we have a hurricane that moves up here, you have a whole plethora of things. You have
Right.
Damaging winds. You have strong tropical storm, hurricane force winds. The storm surge, I think, is some of the hardest hitting for people. Winds can do a number, again, as we've seen from previous storms, a number on the utilities. I think that's going to be a huge thing too. Is that you can trim all the trees back, but you still have huge trees that fall.
Exactly.
So I think the biggest thing that if you have a hurricane is flooding. Definitely the Connecticut River flooded post Irene, and it flooded a considerable stage above what it's used to be. It turned brown too. And everybody's all this runoff that just came into the river turned to brown. A substantial amount of runoff from the rain. So you have that. You have flooding to worry about. You have winds, and the storm surge is going to be even more intense than what we've seen so far from the last 2 hurricanes and cyclones that we've had.
Exactly. Now, you just mentioned that the water turned brown.
Yes.
Why did it turn brown? Just because of all the...
It was a combination. We won't get into too many specifics, but,
all right.
But the biggest one was runoff. We had a substantial amount of runoff, and actually, when the power went out, people's sewers backed up, believe it or not. And the Connecticut River was close to some of these areas that were running off that it had turned brown. Again, this was a large part of runoff that just come from the northern places like Massachusetts, Vermont, northern Connecticut, and come down in. But again, combination of the 2 factors turned it brown. It was rather weird to see. You can go on Google and find some images. It's pretty startling to look at. You're like, that's the river. Okay.
Exactly. Well, studio meteorologist Eric Weglarz, I want to thank you for coming down.
Thank you very much. Thanks for having me.
Hopefully you come down again.
Sounds good.
On behalf of Eric, I'm Pete. Thanks, good night, and we'll see you next week.